Hi, are you ready for more calculus? Me too, we have so much in common. We're gonna do daily lessons 135 and 136. Let's do this thing. So we have a car company introduces a new car for which the number of cars sold, S, is modeled by this function where T is the time in months. Okay, we've got it. If I want to find the value of S prime of 2.5, so you could do this a couple different ways. You could find the derivative of this one. So you could do 300, distribute the 300 throughout. 300 times 5 is 1500 minus 2700 over t plus 2. And it actually wouldn't be too bad to take S prime of t. This would be 0. This second part, I could rewrite this as 2700 t plus 2 to the negative first power. So it wouldn't be too bad because this would be negative 1 times negative 2700. We get 2000, or actually, did I have too many zeros? I think so. This was 3 times 9, or 300 times 9 was just 2700. I have too many zeros there. Okay, so we could do that. We leave the inside alone. It's a negative second power times the derivative of the inside because chain rule. Wow. But the derivative of the inside is just 1. We can rewrite this as 2,700. I did it again. Over t plus 2 squared. So I could do this, or I could just say, you know what? I'm going to just say, I can use my calculator on this one. And I actually already graphed this, but if you go to y equals and you substitute in, or you plot 300, I'm not sure what's on my calculator, 5 minus 9 is alone, so I didn't have to put a parenthesis around it, but you could. But make sure that when you divide that you put x plus 2 in parentheses. And then because I was doing 300 times that whole thing, I need the parenthesis at the end also. So here's the beginning parenthesis over here, in front of the 5, and then at the end. When I changed my window, I know we were talking about months, so I changed it from 0 to 12. And then if we're talking about the number of cars sold, honestly, I just guessed. So I said, well, I want to see below the 0, and then I want to see up to, I don't know, 5,000, and I got something that looked like that. I just want to remind you that if you take second calc, you can go down to dy dx. That will give you the derivative of whatever you put in for x. So right now it looks like nothing happened, but if I just start typing 2.5, and then I push enter, this tells me my derivative, not C, S prime of 2.5 is 133.333. And then I'm going to talk about units in a second. If I went over here and I just did the same thing, just so you can be convinced that we did this the right way, 2700 divided by 2.5 plus 2 squared. Hey, I get the same thing, and part of me was a little bit afraid because I kept multiplying that wrong in the first place. But we get 133.333 what? So this says using correct units. So I want you to think about this. If this was a graph of S of t, and it says where t is the time in months. If I just had a graph, and this were S of t, down here were months, and here on the other side it was the number of cars, so cars. Think about the slope of that line, rise over run. You would get cars per month. We found the rate. So if I want to explain what this value represents in the context of this problem, this is at 2.5. So at 2.5 months, cars are being sold at a rate of 133.333 cars per month. And I know you might say, well, why couldn't we say this? Because you're not going to sell part of a car. You still want to use the 3 places after the decimal unless it specifies, because that 0.333 after 3 different months, it will add up to a whole car, which is a pretty big deal. Okay, the next one says find the average rate of change. Average rate of change. So let's think about that for a second. What is that? Slope of the secant over the first 12 months. So in here, I'm going to say S of 12 Some people will say S of 1 here. Don't do that. We're talking about from the beginning, so the beginning of time, so S of 0 to the end, at the end of 12 months. And 12 minus 0, and then what we do is we go back to this original function. So when I substituted this in, this was S of t. I'm going to do second, calculate the value at 12. And I get 1307.1429 minus the function value at 0, which was 150. And then 12 minus 0 would just be 12. And then I simplify a little bit. So I'm going to say 1307.1429 minus, that was 150, divided by 12. And I get 96.428. Hey, 428, that's my birthday. So 0.428, and then think about what this numerator is. So we found this by saying S of 12 minus S of 0. S was just the number of cars sold. So cars is the numerator. The unit for the denominator was the number of months. The 12 minus 0 is months. Indicate units of measure, we did that. Explain what this value represents. Remember, this was the average rate of change. So we can say 96.428 cars per month was the average rate, or is the average rate of cars being sold from 0 to 12 months. Boom. Okay, and then if I keep going, sorry, I'm closing out the other video. Okay, is it possible for this value of C? Okay, as soon as you see something like this, does there guarantee a value? Is it possible? Is there a value? You should be thinking theorems. So is it possible such that S prime of C is equal to the average rate of change? The average rate of change is equal to the instantaneous rate of change. Which one's that? Average, also known as mean value theorem. So in order for mean value theorem to be applied, the function must be continuous and differentiable, and it has to be from this interval from 0 to 12. Well, what's nice is I can look at this if I want, and I can see this is a nice smooth curve. Nothing's happening, which means this function is not only continuous, but it's also differentiable. The other thing I can do is I look up here and I say, well, t equals -2 was the only problem for S of t. Here, t equals -2 is the only problem. So I'm going to say S of t is differentiable on the interval, closed interval, 0 to 12, and continuous on the interval, and that's the open interval, 0 to 12. Therefore, mean value theorem can be applied. So I gave a reason for my answer already. And then what this is, the mean value theorem is this: the average rate of change is equal to the instantaneous rate of change. This one says if the value of C exists, find the value. So let's actually do this. So I'm going to say S of 12 minus S of 0 over 12 minus 0. And I want that to be equal to S prime of t. S of 12 minus S of 0, I'm going to go back here. We said it was 96.428, but I actually want to use I want the greatest degree of accuracy as possible until I get to my final answer, and there I can stop 3 places after the decimal. So I'm going to actually hope, oh, yeah, it's still there. Instead of writing 96.428, I'm going to actually write 96.428575. And I want that to be equal to S prime of t. S prime of t, we did this up here, was 2700 over t plus 2 squared. Now I need to find that intersection, and it has to be between 0 and 12. That would be the value of c. So I'm going to go over here. I'm going to go to y equals. I'm actually going to push this equal sign just in case I need this later. I don't think I do, but I'm going to do that so that it's not highlighted anymore. 2700 divided by the quantity x plus 2 squared. And I'm also going to graph 96.428575. And I just want to make sure my window has that in it. Yeah, my y max is huge, so it's well above 96. So when I graph it, it's even a little bit hard to see because my graph's so big. So you know what? I'm going to change my window, and in my y max, why don't I just go up to 100 now? Because I know the highest value that I need to see is 96. Well, it's well up there, but whatever. Now I can do second, calculate, intersect, enter, enter, enter. And I can see that this intersection, this is at x equals 3.2915025. And I want to check, is that within 0 to 12? Yes. Or I could have just said 1. I'm not even going to say months because it didn't ask for me. But I can say c is equal to 3.291. We did it. Yeah, that's it on this one. So we showed mean value theorem applied. We said differentiable continuous. We showed what mean value theorem was by writing this. We are good to go. But you want more practice. Is that what you said? It's so weird how video works. Like, I thought I was just talking to you, but you're like talking to me back. You're like, please, please, can we do more calculus? And you might be saying no. That's not what I said. I said to stop. But what's really happening is I can hear, keep going. We have a table. We haven't had one of those in days. And look at all this. F, F prime, G, G prime. This is our lucky day. And it says the functions F and G are differentiable. That means their composite functions are also going to be differentiable. And it says strictly increasing. This does not mean like we're really harsh. Strictly increasing means there's never going to be a place where the derivative is 0. The derivative is always going to be positive for G. So G is strictly increasing. That means G prime is always greater than 0. And then it says the table above gives the values of the functions in the first derivatives. Select the value of x. Great, great, great. The function h is defined by this bad boy, f of g of x minus x. Find the equation of a tangent line. I didn't know we were going to get to do this. Actually, yes, I did, because, you know, this is my stuff. But find the equation of the tangent line. You should do that. You need what? Slope and a point. Okay, so go ahead, do it. For my point, I'm going to find h of 3. H of 3 would be f of g of 3 minus 6. Starting the inside out, so g of 3 would be 4. So I'm really looking for f of negative 2. F of, something's wrong here. What did I do wrong? G of 3 is 4. Oh, silly me. Do you see how it says f of g of x minus 6? So this would be f of 4 minus 6. Maybe you did that too. Maybe I was just showing you. And I did this on purpose. Probably not, because I just wrote all over my paper. But f of 4 was negative 1 minus 6. Hey, we have a point. So when I do y minus y1 and m times x minus x1, got my x value, I've got my y value. Okay, we're good so far. Keep going. And then the next thing that I do is I want to find the slope of the tangent. The slope of the tangent is also known as the derivative. So h prime of x. Wow. The derivative of the outside. Chain rule. Leave the inside alone. Times the derivative of the inside. The derivative of negative 6 is just 0. H prime of 3 is going to be f prime of g of 3 times g prime of 3. F prime g of 3 is 4. G prime of 3 is 2. So close. F prime of 4 is 3 times 2, and I get 6. Huzzah! We did it! Let's keep going. Find the rate of change of h on the interval from 1 to 3. So it's over an entire interval, it's not in a moment. You should be thinking slope of the secant line from 1 to 3, the average rate of change. So h of 3 minus h of 1 over 3 minus 1. What's nice is we actually already found h of 3 was negative 7. We need to find h of 1. H of 1, if I do that over here, was f of g of 1 minus 6. G of 1 was 2. F of 2 is 9 minus 6, and I get 3. I'm checking my work with old me and making sure that we agree. I do. But again, if I say old me, does that really mean old me? Because I'm older than when I wrote it the first time. So which one is old me? Existential questions. You weren't expecting that right now. I like to throw in things that you weren't really expecting. Okay, this would be negative 10 over 2, which is also known as negative 5. There are no units, so I'm not going to put any units here. Okay, the next two. Do you see how this, it says explain why there must be a value, explain why there is a value. Theorems. So in this one, where h of r is equal to negative 2. Okay, let's think. This doesn't say anything about the derivative. So it's not going to be mean value theorem. It's not the derivative is equal to 0, so it's not going to be rules. It's not about this being the highest point or lowest point, or like meaning the absolute max or the absolute min. So it's not going to be the extreme value theorem. But there is one from a long time ago, intermediate value theorem. Let's see. First, is this function differentiable or continuous? Well, I'm going to say as f and g are differentiable. That was given. H is differentiable. Therefore continuous. So really important. Every theorem needs continuity in some way. Did you think the theorem yet? Which one this is? Intermediate value theorem. But if I look and I see a value, we know h of 1 and h of 3. And do I know that negative 5 is in between there? I shouldn't have put this way. This could have been greater than and greater than. So let's check it out. H of 1 we knew was 3. H of 3 was negative 7. So yes, I definitely shouldn't have put that in there. There we go. So I can say negative 5 is between h of 1 and h of 3. Why did I write negative 5? This is a negative 2. I can read numbers. I think I wrote negative 5 because it was up here. Negative 2. Did anyone else catch that yet? There we go. But it's still going to be the case. Negative 7 is less than negative 2, which is less than 3. So negative 2 is between h of 1 and h of 3. Therefore, IVT guarantees such a value of r for 1 is less than r is less than 3, such that h of r equals negative 2. Meaning if I am going the whole way on a graph from negative 7 to a positive 3, I have to pass through negative 2, and it has to be somewhere within that interval. It could be more than once. Explain why there is a value of c. By the way, I don't have to find that value. I can't find that value. Not like this. I would need more information. Explain why there is a value of c, 1 through c, such that h prime c is equal to negative 5. Okay, as soon as you're thinking about derivatives, I've got derivatives. My first thought, unless I've got a table of derivatives, and then I can go back to intermediate value theorem, but h prime, my first thought is either MVT or rolls. For rolls, you only can have h prime equal to 0. For MVT, there's a little bit more leeway. And I can see right here, I'm like, negative 5, where did I see that before? Well, I wrote it incorrectly here because I saw it here. What? So I'm going to say f and g are differentiable. Therefore, h of x is differentiable. Therefore, continuous. And MVT applies, or can be applied. Which means if I take h of 3 minus h of 1, 3 minus 1, I'm showing it's somewhere equal to h prime of c. And we already said that this was equal to -5. C part B. And this is important. If you do this on the AP exam, if you want somebody, like whoever's grading it, to go back to part A or part B, and you're writing this in a different part, you can't just assume they'll look back. In fact, they won't look at anything outside of what you wrote in a box unless you say, hey, go see this part. And then they'll be like, oh, okay, great, I will. So -5 is equal to h prime of c. This is just a good habit to get into. So f and g are differentiable, MVT applies. I'm showing this work here. So you can say, therefore there must be a value. There must be such a value. Of c. In 1 is less than c is less than 3. I can't help myself. Okay, now I'm done. We did it! Thanks for sticking with me. Please let me know if you have any questions. You're awesome. Bye!